I'm Dr. Karen Rader. I'm in the VCU Department of History, and I direct, along with John Powers, the STS program, which stands for Science, Technology, and Society. As always, we are glad to have you here. This is the second in the 2017-2018 STS lecture series, Science Fact, Science Fiction, which I'll say a little bit about in a moment. But before that, I want to really say that we're fortunate to be able to rely on our home department and other VCU collaborators for support, including the VCU Department of History and its chair, John Kneebone. And in this event, we had further support from Dr. Rob Tomes, who is over here, the VCU School of Life Sciences. So thank you to our co-sponsors. This talk, like the STS series, is also made possible through the program support of the College of Humanities and Sciences, whose Dean, Montserrat Fuentes, supports us, as well as a National Science Foundation grant. NSF made possible some community-engaged research that I am doing with Science Pub RVA. You may have seen those posters or Facebook posts or Twitter. Cynthia Gibbs, the Science Pub RVA director, is also my research collaborator, so I want to thank her. She will be running the Science Cafe taking place tonight at Capitol Ale House downtown, so if you can't get enough of Stuart Firestein, you can go at 6 p.m. down to Capitol Ale House and hear more there. So just to remind folks, this year's STS series explores how representations of science and scientific ideas in media and culture relate to actual scientific practices, and in turn, how these representations are understood, interpreted, and circulated in wider society and culture. So there's more information about this on our webpage, our Facebook and Twitter feeds. We are STS at VCU if you want to learn more. Last month, we heard from Dr. Evelyn Hammond, who talked about the marginalization of women of color's voices in STEM, and how those stories, those missing voices, have reasserted themselves in both historical and contemporary science policy. This month, we are going to hear about a set of what I think of as missing values in the representation of doing science, namely all of the ones up there, which I will read out of order: doubt, uncertainty, ignorance, and failure. And really, no one is more qualified to talk about these things than Dr. Stuart Firestein.
Well, thank you so much.
So at the beginning of his 2012 book, Ignorance, What Drives Science, Stuart Firestein notes the irony of being just such a self-proclaimed subject area specialist. He says that when he taught a course, Ignorance, it was called Ignorance, to Columbia University graduate students, he pondered whether these folks would want to boast that they had earned an A or an F on the subject in their transcript. But Dr. Firestein, who is no longer chair of the Department of Biological Sciences at Columbia University, but was, and who is a successful scientist in his own right, advocates repeatedly and publicly, as in a popular 2013 TED Talk, that scientists must actively pursue understanding their own ignorance and failures in order to do good work. He runs a lab full of neuroscientists in training. They study the vertebrate olfactory system, what he calls, quote, possibly the best chemical detector on the face of the planet, unquote.
And on your face, too.
And on my face, too.
It turns out.
Which is apparently not on the planet. But, and Firestein says that this work will help them answer what he calls, again quoting, a fundamental human question: how do I smell? Specifically, these researchers examine various chemicals such as neurotransmitters, hormones, peptides with membrane receptors, and the ways in which these substances exert their influence in living things, a phenomenon for the non-scientifically inclined called signal transduction. So you can ask him more about this work in the Q&A, but now without further delay, please help me give a warm VCU welcome to our invited specialist on doubt, ignorance, uncertainty, and failure, Dr. Stuart Firestein.
Thank you, Karen. Thank you all. This works, yes? Okay, good. Thank you all. Thanks so much for this invitation. This is a real opportunity for me. I'd like to just plug the Science Cafe tonight. I am totally different on beer, so could be worth your time. I want to say a couple of things as a sort of a preamble to this talk, because it's a little different than the sort of standard thing I've been running around doing with ignorance, failure, doubt, and uncertainty, because this is a group of people who have, among you historians, philosophers, I think probably sociologists and so forth of science. And so the first thing I want to say about it is that I don't think I'm going to tell you anything particularly new today, and that's okay. That's part of the plan. I think an awful lot of what I say you will recognize as something you already know or believe. I think the issue is that what I'd like to do is take things that we all recognize implicitly and make them explicit, because often I find making them explicit makes a difference in the way we view them and the way we think about them, gives us a chance to rethink them, and also makes us think about the way we communicate them to a larger audience, and so remove ourselves from some elite level. The second thing is that I'm trying to, I have this little niche here, as Karen pointed out, this ignorance failure niche that I've developed for myself, which I'm trying to expand a little bit. So I'm working currently on a kind of a new set of ideas, and I'm going to use the end of this talk to present some of those in their very, very early stages, because I'm really interested in your feedback. So the end of this talk will not have a rousing sort of bang, pop, applause thing. It will just, I hope, devolve into chaotic discussion. That's my hope for it anyway, so don't think twice about that. All right, so I think having said all of that, let me start out. So some of you will have read this book that I have on ignorance and another one on failure, but many of you won't, so I'm going to try and get us all on the same page. And this is a phrase that I use in this book, but that I think is, if that's for me, I'll take it later. All right. This is an idea that I think is extremely important that I ran across. It's an anonymous old aphorism which says it's very difficult to find a black cat in a dark room, especially when there is no cat. And I think this is, in my opinion, the perfect description of the scientific process, of how science actually works. That we spend most of our time in dark rooms looking for black cats, which are hard enough to find, but we don't even know whether they're there. There's some report of a black cat in the area. Maybe it's reliable, maybe it's not. And if we find this black cat, the thing we mostly do right then and there is move into another dark room and look for its relative black cat. And so this is kind of the way science works. Now this is, I would say, opposed to what we typically teach and talk about in public, which is the vaunted scientific method, which I am against, and you may have heard some rant by me somewhere, or seen some rant about it online. I'll try and keep myself calm today. But I think the scientific method is one of the worst ideas that we promulgate, both in educationally and in public discussion. And I'll go into a little bit why, because I think really in the black cat idea, the black cat metaphor, what we really do is kind of this, to be honest with you, and we kind of do it like this. And so that's really how science proceeds. So what's wrong with this scientific method? I think, first of all, it's kind of largely just a shorthand. And it can be a useful shorthand early on, but then we leave it sort of in place. It's a shorthand for describing quickly how a scientific process could work, or what the fundamentals of it are. But it leaves a lot out. So of course, this is the way it works. You know, it's an iterative kind of process. You observe something, you develop a hypothesis about what that might be, how it might work. You do some tests or experiments, you revise your hypothesis, so based on new observations, and you do this iteratively. The problem with this scheme is, in my opinion, the one crucial element of it, because the observation, the testing and experimenting and all that, that's not so hard to figure out. But the one crucial element, this hypothesis business here, it tells you nothing about. I mean, how do you go about getting this hypothesis? Is there a book of hypotheses? You look them up somewhere and choose a couple of good ones and hope for the best? So where does this hypothesis come from? Because this is the central issue. So I would say we'd be better off, instead of looking at the scientific method, to look at what I call the scientific process, which I'm going to suggest to you, and I hope to develop, consists of things like what we don't know, some kind of intuition about it, some observation and experiment, of course, probably a failure that follows that, a new question, some inspiration, one hopes, after you wait around for a while. That probably leads to a failure of some sort. So you revise, you have an interim explanation, you fail again most likely, and eventually you maybe end up, if you're lucky, with a better question at the very least. So the thing about these things here is they encompass all of that other scientific method, but they also leave room for intuition, inspiration, curiosity, creativity, words that you never hear associated with science, but are the core of how science actually works. And so that's why I don't like the scientific method, because it sounds like a recipe. It sounds like you put stuff in the hopper here, you turn the crank a couple times, and out pop the gadgets and the cures and so forth. And that's just not the way it works. There is no recipe, and scientists are not a brotherhood or a sisterhood, if you will, of people who march in lockstep according to a set of rules that we all simply follow. This just has little or nothing to do with the process. And so there's my rant about the scientific method. So I like to use this quote from Marie Curie because I think it really encapsulates this idea of what we don't know being important. This is from a letter that she wrote to her brother upon achieving her second graduate degree. So she knew a lot of stuff. But for her, she never noticed what has been done. One can only see what remains to be done. And I thought, well, it's what the remains to be done that is indeed the key to the process of science and the key to thinking about science. And also, I believe, is the most accessible part of science to even the so-called non-expert. I have to use this joke, I'm sorry, because I always get a kick out of the fact, I use this picture of Madame Curie because it's one of my favorites, because I'm convinced that that glow behind her is not a photographic effect. I believe that's actually the real thing, you know. Indeed, I must say that her papers today, her notebooks today, are stored in a basement room in the Bibliothèque Nationale Française, and it's lined in lead. And if you want to work on her notebooks as a scholar, you have to have a radiation suit and all that. And I would also say that from many of her notes and essays, it's clear she knew what she was about and what the dangers were, or many of the dangers. And I think that's another part of science, which I don't have time to talk about today, which is important, which is courage, and a word that we often leave out of the scientific process. In any case, what remains to be done? So there's this notion that we have some knowledge, and what I'd like to suggest is that the more we increase knowledge, the more we increase our ignorance as well. And a kind of a model for this, I think Charles Saunders Peirce, the historian, philosopher, scientist, et cetera, was one of the first to come up with it. It's been repeated in many ways. If you think of knowledge as this sort of circle of light here and all this ignorance out here, well, you know, as the circumference as the size, the area of knowledge increases, so does the circumference by what's, 6 times pi or something to that effect. And so as you increase knowledge, you also, of course, increase sort of the amount of ignorance that we're in touch with. And this is the notion of science, that we are really using knowledge, if you will, to increase our ignorance. I'll use a couple of quotes here. This is from George Bernard Shaw. It was a toast to in a dinner celebrating Einstein, actually, in which he said, "Science is always wrong, never solves a problem without creating 10 more, which I find glorious somehow or another and very good for your job protection. He actually cribbed this apparently from Immanuel Kant, who had this principle of question propagation, the idea being that every experience begets a fresh question. In a kind of Shavian way, he just increased it by an order of magnitude, I think, 10 more, so that's typical, but I think he's right. So we could say that knowledge is a big subject. Many people study it. Indeed, one of the things we worry about with scientific knowledge is that it grows at what appears to be a kind of an exponential rate. These are some numbers from a little while ago. And this leads, I think, very easily to what we would call the accumulation model of science, and it's a cumulative effort, and it is to some extent, but eventually you have a pile of stuff so big that it seems somehow or another impregnable. It's just impossible to keep up with the literature, to keep up with all of it. And so we wind up with this accumulation model of science that I think is off-putting in many ways. I'll borrow sort of a rephrase a line from Pascal, in which he asked if a house is certainly more than a pile of stones, and so science should somehow or another be more than simply a pile of facts. And so that's what I want to talk about, is the what's more than a pile of facts. So if knowledge is a big subject, I'd like to suggest to you that ignorance is, of course, a bigger one. I told you I wasn't going to tell you anything we don't already know. I'll use another quote here. I use a lot of quotes here. I don't want you to think I'm using these quotes because I think they gives anything more authority. I just think if smart people said something smart, they shouldn't be left out of the conversation just because they're dead. You wouldn't like that, right? I think it's also important to recognize that this conversation has been going on for a long time in a lot of different areas among philosophers, historians, scientists, et cetera, and that our job is to get into the conversation and leave something new behind if we can. In any case, this is a quote from James Clerk Maxwell, arguably the greatest physicist mind between Newton and Einstein, in which he said, "Thoroughly conscious ignorance is the prelude to every real advance in science." And so it's this notion of thoroughly conscious ignorance. Of course, I use the word ignorance to be at least partly provocative, but I don't mean stupidity. I don't mean a callow indifference to fact or the kind of things you see among elected officials, for example, too often, but rather this notion of thoroughly conscious ignorance. So So this is sort of the standard way I think we think about things. We don't know something, we go to school, we read books, we try things, and we gain some knowledge. I'd like to suggest that this arrow can be reversed as well. That what do we do with this knowledge once we get it? Well, I think the purpose of most of our knowledge is to provide us with better questions, to come up with a more sophisticated, better version of ignorance. That there is, if you will, what I would call low-quality ignorance and high-quality ignorance. Ignorance is too small a word to encompass it all. But there's a lower quality and a higher quality ignorance, and scientists, at least, I think, argue about this all the time. I mean, sometimes we call them bull sessions, and sometimes we call them grant proposals, and sometimes you can't tell the difference, I admit. But nonetheless, that's what the argument is about. What's the high quality ignorance? And this is what we use, whatever knowledge we gain, we use it to ask a better question, if you will. So you could say, instead of ignorance, you could say questions. I'll use an example here. This is I. Rabi, the famous physicist who was at Columbia University, in fact, won a Nobel Prize in 1944 for his more or less invention and development of nuclear magnetic resonance, a technique still very important today in chemistry, and what turned into magnetic resonance imaging in the medical diagnostic world. And Rabi, who I unfortunately never knew, but I know people who knew him and who tell the story, a story that he apparently loved to tell, that growing up, as I think it's important to say, as an immigrant child on the Lower East Side of New York, he and his friends would come home from school and their mothers would say, so what did you learn in school today? But Rabi's mother used to say to him, so Isidore, did you ask any good questions today? And I think that's a huge difference. I think that's a huge, important difference. So Rabi's got a Nobel Prize. I don't know about his friends. I'm sure they did okay too. I don't know. But I think Mrs. Rabi had the right idea. When you come home from school, the issue is, did you ask any good questions today? So I'd say the search for better ignorance is kind of what we're about. And I'd like to introduce a term here that actually comes from the poet John Keats, and that's this term negative capability. I want to stress it. I'm going to come back to it again. I think it's one of the most important ideas one can have. It sounds a little bit oxymoronic, perhaps, but so negative capability is something Keats defined in a letter to his brother also, as it turns out. When a man, now we would say a person, I hope, is capable of being in uncertainties, mysteries, and doubts without any irritable reaching after fact and reason. He considered this to be the ideal creative state. So the notion is patience with ignorance, patience with mystery, with doubt, with uncertainty, because this is when you are most creative. This is when you are most likely to have an inspiration. And so this idea of negative capability and developing negative capability in ourselves, in our students, in a wider public, I think is crucial to the idea of the way science proceeds and grows and the way it impacts in society. Sort of restated in some way, I don't think he knew it, but Erwin Schrödinger has a sort of scientific statement about it. Put these on here because I think Schrödinger, kind of knew something about cats, or didn't, as the case may be. Right? But Schrödinger said, in an honest search for knowledge, you quite often have to abide by ignorance for an indefinite period. This ability, again, to abide by ignorance for an indefinite period takes a kind of courage and the kind of patience that I think we too often leave out of the scientific process now. All right, now I'm sorry, I have to introduce this guy here. I know this is not a happy thing for some of you in the room. This is Donald Rumsfeld, for the younger folks in the room who may not know him. He was the Secretary of Defense during the Bush administration and the architect of our two somewhat ill-begotten adventures, you could call them, in Afghanistan and Iraq. And during a Senate testimony, Rumsfeld had the following thing to say about why things went awry there. So there were all these things we didn't know about that we found out that we were there. But the real problem were the unknown unknowns, the ones we didn't even know we didn't know. Now, he was roundly ridiculed for this. It was actually a clever statement. Unfortunately, he's not the first person to have said it. Whew, which is a good thing. So it took me a while to find out what the actual source of this was, but I'm proud of having done it, so I'm going to tell you. It actually comes, apparently, its early issues comes from a poem, a long poem by D.H. Lawrence called New Heaven and Earth, and it's this rather long, epic piece of poetry about a transition between this life and an afterlife of some sort. And towards the end of it, there's this verse: now here was I, new awakened, my hand stretching out and touching the unknown, the real unknown, the unknown unknown. And so it's this idea of an unknown unknown as being the real unknown. So if we believe that ignorance is important, then the deepest kind of ignorance, it seems to me, is not just the stuff you don't know, but the stuff you don't know you don't know. This is the real, deepest kind of ignorance. So then the question comes, well, how do you get to the unknown unknown? How do you find out about what you don't know you don't know? And I would say the best method we have developed for that so far is failure. Because when you fail, when you do an experiment in order to gain some knowledge, because you don't know something, you think, well, I'll do this experiment, then I'll know it, and then the experiment doesn't work, now you know that there's something else you didn't know that you didn't know before. You get the drift, right? And so I think failure is the way into this kind of unknown unknown. I use another quote from Benjamin Franklin, arguably the first American scientist. Perhaps the history of errors in mankind, all things considered, is more valuable and interesting than that of their discoveries. Because after all, truth and fact is uniform and narrow. But error, you can screw up in endless possible ways, right? This is, I think, sometimes called the Anna Karenina principle after Tolstoy, who was once asked why he never wrote about happy families. He always wrote about really dysfunctional families. And he said, well, all happy families are happy in the same way. But unhappy families, oh, they have all sorts of ways, plenty to write about. So I think this is true, though, that I mean, it's nice to get some facts, it's nice to make some discoveries, to get some truth here and there, but it is rather narrow, it is rather finished, whereas errors are endlessly interesting and diverse. So here are some ideas about failure that I would like to disabuse you of, because they belong, I think, more to the self-help literature, if you will, than to my idea about failure in science, which I'd like to develop more deeply. So one is, this is often attributed to Winston Churchill, although in fact he never said it. So there are several people, I learned because I use these quotes a lot, you have to track them down, and there are several people who get credit for a lot of stuff they never said. Winston Churchill, Abraham Lincoln, Mark Twain, and Voltaire are the top winners in this area. More stuff that they never said that they get credit for. Anyway, this was supposedly Winston Churchill. Success is learning to fail again and again with no lack of enthusiasm. Fail hard, fail fast. This is a favorite in the tech industry right now, although I don't think they know what it means. This actually was said by Thomas Edison, that he discovered 10,000 ways it didn't work while he was trying to invent the light bulb, which is curious because now we use the light bulb as like click, oh, I got an idea. Figured it out. But he actually failed 10,000 times first, according to him. Failure is the opportunity to begin again more intelligently. That's good. This actually, I was in a Chinese restaurant, and this was in the fortune cookie, so I took a picture of it. Failure is opportunity in disguise. And this is, I don't know why I include this. This is from the actress Gloria Swanson, who only a few of us in the room will remember. Said, if you're over 40 years old and never had a failure, you've been deprived. I'm not really sure what she's referring to there. But so these sort of bromides are all fine and dandy, I think, if you have someone on the phone who's just failed in sport or love or business or something like that, and you need to pep them up a little. But they have nothing to do with the kind of failure that I think is endemic and part of science and a crucial part of science. And it's a little bit of harder failure to get your head around. So I'm going to use a couple of quotes. My favorite is this one, and this I would say is the failure version of negative capability. That a real failure does not need an excuse. It is an end in itself. The notion of a failure which is simply an end in itself. And this one, which comes from Samuel Beckett, ever tried, ever failed, no matter, try again, and then fail better. So at first this just sounds like one of those bromides, you know, try, fail, try again. And then he comes up with this fail better. I mean, is there a way to fail better? Is there a way to have better ignorance? Is there a way to have better failure? I believe the answer to both those questions is yes, but it takes some thought. So this was the enigmatic Samuel Beckett. The important thing about failure is that it's not only valuable retrospectively, that failure is not good because eventually it leads to success, because it teaches you perseverance, because you have to do trial and I mean, all of those things are true, but that's not the primary reason that failure is valuable. Failure is an endemic part of the process of science and learning. It can't be left out, it can't be avoided, but I think it can be utilized and I think it can be improved. And that's sort of the challenge with failure. And that's why I say it's an end in itself. You cannot have a scientific effort without having failure. So for example, one way of thinking of failure in the slightly cheaper but still useful way is serendipity, right? So this is the retroactive value of failure. This is that you failed, but eventually, oh, your failed experiment, but oh, look at that, I discovered something I never expected, right? And that's useful, but And at one point I thought I would write a third book on serendipity, but then I gave that up because I've become less and less enchanted with the idea of serendipity, which has about it the idea of dumb luck. But I don't think serendipity happens from dumb luck. Lawyers do not make serendipitous scientific discoveries. I mean, they do law, and scientists don't make serendipitous jurisprudence kinds of statements, right? You have to be working at something, and then you also have to be smart enough to recognize that in a failure is possibly something as interesting or more interesting than what you were looking at. So this is the famous quote about that from Louis Pasteur, who was indeed the benefactor, the beneficiary of a lot of serendipity, I suppose, and that's that chance favors the prepared mind. And I say my corollary to that is that failure also favors the prepared mind. And that's where it's useful. What's next? Okay. So we gain knowledge of ignorance through failures. Oh, sorry. I know I'm loading up quotes here. Sorry, I try and be more selective sometimes, but this is a good one from Enrico Fermi, the famous physicist, who was reportedly used to tell his graduate students and postdocs and all that if you do an experiment and it proves the hypotheses, you've made a measurement. But if you do an experiment that fails to prove the hypotheses, you've made a discovery. And I think what's important to recognize here is that both of these things are crucial to the advancement of science. Measurements are crucial, but so are discoveries. And so this is where failure is endemic to the process. Here's the obligatory, sorry, not yet. Later will be the obligatory. So, all right, so let's say I've convinced you about ignorance and failure now. So we could ask a couple questions about failure, one of which would be, how much failure? Can you fail 100% of the time? I'm guessing not. But I do think we seriously underestimate the amount of failure that's acceptable. So I'll use, I think, either one or two examples. This example I'll use from nature, if you will. All of these animals pictured here are at the top of the food chain. They are evolution's winners, as it were. They're the king of their particular niche, the land, the sea, the air, whatever. And I'm sure that most of you believe that anytime they get a little hungry, they can just go out and bag some snack, right? And that's it, a rabbit, a deer, a fish, whatever it is they want. But in fact, if you look into the predator-prey literature, you find that they are successful on fewer than 25%, and that's the high watermark, fewer than 25% of their tries. So a lion goes out looking for something to eat, and 75% of the time it does not bag that prey animal. That's why there's so many prey animals still left in the world, right? There are herds of them all over the place, right? And so these animals actually fail some 70 to 75% of the time, and yet as a 75% failure rate puts them at the top of the food chain. Yeah, this is the obligatory New Yorker cartoon, right? So I'm not sure you can make golf any more fun than it is no matter what you do, but certainly it wouldn't be fun if the hole were this big, right? And so failure is also typically a part of a lot of athletics. And we recognize it there more easily, right? We take a goal of some sort in an athletic game. Here, get this ball into that big thing over there. But you can't use your hands. You know, and we somehow or another enjoy this idea of crippling ourselves, making failure more likely, because of course then success becomes somehow or another more meaningful, at least because you can be more confident in it. This success was earned somehow or another. So another question we could ask is, how big a failure? Let's go for the biggest possible failure. How about a debacle, right? A debacle in its current usage means an unmitigated disaster, a total failure. But the word has an interesting etymology. It comes from the French débâcler, which is sort of old French now, and it means to free, to unbar, or to unleash. It originally had a nautical meaning. It was used for ice breaking and so forth. But it does then capture this idea of breaking up some solid mass in order to find a new pathway. This sounds a little bit like words we toss around like innovation and things like that, right, that we just flip off. But this is actually maybe how to do that. So we often think, you know, these creativity workshops, creative people can associate ideas from all different places. But I would say that it may more powerfully come from dissociating ideas that have been too long associated. That this is actually a more powerful way to think creatively, and that requires a kind of failure. This is Ortega y Gasset, a philosopher of the 20th century, in which he said it costs more to dissociate ideas than to associate them. And we still use this word, breakthrough, right, for some big discovery. And so tucked in that word is the notion of breaking shit up here. Let's break some stuff and see what happens when it fails, because that's often where the most creative times come from. So, all right, so I think I've had two key concepts that for this sort of first section, major section of the talk. Negative capability, the notion of remaining in doubt and mystery, uncertainty, having patience with ignorance. And then failure being an end in itself, this idea that it's integral to the process and that one can learn to fail better. All right, so I have ignorance and failure here. Now, where's that going to lead? Well, we have stagnation, we have despair, we have desolation, we have drink and tobacco and all sorts of other things that we can help ourselves with and all that. But I'd like to suggest, and this is the new part of things where I don't know where I'm talking about, okay, but I'm thinking about. I'd like to suggest that the next thing after ignorance and failure are indeed not these, but it's actually what I would call optimism, or what I'm currently calling optimistics, which is a made-up word. But optimistics is a sort of a study of optimism, shall we say. And I'd like to suggest that, okay, so, all right, right. So once again, though, I want to disabuse us of the typical idea of optimism, that optimism is littered with glasses that are half full or smiley faces, get rid of that guy, right? That this is not the kind of optimism I mean. And I'm talking about a certain kind of optimism that I believe, I'll make the strongest possible statement about it I can, which I'm not positive I can defend, but I would say that a kind of optimism that, in a sense, science invented, that arrived in our culture along with the scientific revolution. And here's my case for that to the extent that I can make it. So what are the elements of scientific optimism? Here's a kind of a provisional list. Progress, the idea of wonder or astonishment or awe, aspiration, that we can know things, understanding and explanation, but not necessarily truth with that capital T kind of idea, that the world, the universe is unlimited, unbounded, that we have amazing large numbers. So I think like Avogadro's number, which is this 5 point something times 10 to the 23rd, all these zeros. I find that a very optimistic idea. Really? There's something that big out there? There's that much stuff of some kind out there that we can't really conceive of, but somehow or another we can get our head around it and use it. And also the notion of long time. So I think a world that believes it's only about 6,000 years old and thinks it's going to end in the next couple of decades in some apocalyptic flame out is not likely to entertain many optimistic or progressive thoughts. But once you think that the world might be, that the universe might be 13 billion years old, and that at least if something doesn't get it like us before entropy, it has another 13 billion years or so left in it. So this notion of an unlimited, unbounded kind of universe. It's generational and continuous, that is, we pass it along. This optimism that we can find things out, it doesn't have to be found out just in my lifetime. This is this sort of standing on the shoulders of giants idea. It includes both hubris and humility. I think that's one of the interesting things about science. On the one hand, I think to be a scientist, you have to have a tremendous amount of hubris. I'm going to figure this out. I could figure out how the planets circle the sun and what governs the way they do it and all the rest. I can figure all of that out. It takes tremendous hubris, I think, for people like a Newton or a Kepler or a Einstein in more modern days, and even scientists today, to keep it work. At the same time, you are faced with a great deal of humility because most of what you do doesn't really work out so well, or doesn't work out the way you'd hope to. But it also has to do with this standing on the shoulders of giants. And I should say the standing on the shoulders of giants is, I think, an important phrase, because the other reason that I think optimism, I'm pushing this on you, but the reason I think optimism kind of started with the scientific revolution, or at least late Renaissance ideas, was that earlier philosophies, even the Greeks, who we admire a great deal, earlier philosophies tended to have an idea of regression, I would say, rather than progression. There was the idea of a golden age. There was a previous time when things were better, and we're living in some decrepit version of that. Maybe we can get back to it, be it a fall from grace in the sort of Judeo-Christian world, picture of the world, or the Homeric golden age of the Greeks. It was always a look back rather than a look forward. So you could improve things in your current life. You could make little adjustments. You could improve the way buildings got built or navigational techniques. But there wasn't a real sense of a long-term progress, it seems to me, in the same way that we have now. Skepticism is part of scientific optimism. That's a trickier one. It's I think, pluralistic and liberal in its thinking, or should be. That's a whole other issue we could have talked about, but I'm not going to do that today. And it's also, I think, importantly, anti-authoritarian and most of the time democratic and meritocratic, although that sometimes gets mucked up as well. But it certainly is anti-authoritarian. I'm not going to go through all 10 of these points, don't worry. But I will take progress for a moment. Because progress, I think, is, again, one of these words that we all think we know what it means. We think it's been with us for forever. It just seems an indelible part of our civilization, our lives, the way things are. I mean, you know, the Bronze Age, which lasted about 50 generations, people were born, grew up, and died in precisely the same technology. Now you go away on a vacation for 2 weeks and you're like hopelessly 2 operating systems behind or something, and who knows what else has happened while you're gone. So clearly this idea of progress has somehow changed a bit in the last several years, at least in terms of its rate, and the rate of its rate has changed. Forget where I was going with that exactly, but in any case, all right. But it turns out, I've learned, that at least among philosophers, and I believe historians as well, this is not such a settled idea. That progress, although we think of it now as something that's kind of always been around and it's an indelible part of our lives, is a relatively new idea. As I said, I don't believe the Greeks, the ancient Greeks, or much of medieval thought was directed towards this kind of progress. It was mostly a kind of authoritarian place to get knowledge and a look back rather than forward in general. So we could look at this sort of quasi-historically. I'm not a historian, so I'm just doing the best I can here, which is why I'd like to hear from other people in the room. So you could say this sort of started with Francis Bacon. I mean, a lot of people put that as more or less the beginning of the scientific revolution in the late 17th or sort of early 17th century. So the scientific method, which I ranted on before, was his, and I don't agree with it, but it was a good beginning in any case. He also was very big on the utility of knowledge, that science should be only done for useful things. I actually don't like Bacon at all, but he was at the beginning of this, so I have to give him credit for that. Galileo, of course, in several of his famous publications, but in particular this one in which he found that mathematics and inductive reasoning were a way towards explaining large events. Of course, Descartes, discourse on the method, and et cetera, et cetera. And this was, I think, the beginning of a kind of anti-authoritarianism, this notion that knowledge could not be gotten just simply from an authority, whether it was a deity or Aristotle. They were not dependable places for knowledge, that knowledge had to be somehow or another through reason, and that it could be discovered that knowledge that was useful was invariant. Newton, of course, with the Principia, this idea of universal gravitation and a lawfulness that went throughout the universe, that was boundless, that opened up the entire universe to the possibility of our knowing it. Leibniz is a curious one because, of course, his was the best of all possible worlds idea, which it seems was one of the earliest mentions, the earliest ideas about optimism in Western literature, especially Western scientific literature, but it's curiously not very optimistic, or at least is often interpreted as being not very optimistic. You know, it became a source of satire in Candide, in Voltaire's Candide, this notion that an all-powerful creator would never create a world that was not the best of all possible worlds. And so even though there's evil and misery and this and that in it, it still is better than a world without those things, even though we, mere mortals, can't possibly see this. And so the world we live in is the best of all possible worlds. He considered that optimistic. I think of it as kind of pessimistic. It's like, well, this is it. Like it or leave it, you know, it's kind of it. So there's not much to be done. And then there's this fellow who I think is not very well remembered or regarded, and Bernard de Fontenelle, who was a French scientist of high reputation in his day, but somewhat forgotten. He wrote this interesting book called Conversations on the Plurality of Worlds, which was actually a kind of a manual of astronomy and physics, directed, believe it or not, at an audience of women who were not able to go to school and so forth. And so it was an attempt to explain to a general public, or to a public that otherwise had no access to the inner sanctum, how the universe worked. And it was actually quite a successful book, and it was a lot of people bought it and all the rest of that. And what it did was it got all of this stuff into the culture. It moved the idea of science into the wider culture, and I think along with it, the idea of scientific optimism. All right, so here's the way I sort of see it, okay? And then I'm going to kind of end, I think, more or less on this, and then we can talk about this. You can tell me why I'm dead wrong about all of it. So I think the first thing science does when it comes around the beginning of the end of, more or less the end of the Renaissance, is it invents ignorance. This is still its biggest and best invention. It invents ignorance because it says the source of knowledge is not authority. You can't just take what Aristotle said or what the church tells you. You have to do experiments. That's no longer a part of knowledge. So suddenly, scientists increased ignorance massively, right? Because everything you thought you knew, throw that out. Now we have nothing but stuff we don't know. So how are we going to find out what we don't know? So science comes up with experiments. Well, we'll do experiments. We'll make empirical observations, and we'll use induction, deduction, all these sorts of things, and that's how we'll gain new knowledge. The problem is that when you start with experiments, you introduce this failure problem, because most experiments don't work. So science now has to invent some non-catastrophic means of failing, because if all you did was fail, if your experiments kept failing, you'd kind of lose interest after a while, I think. And so things like, I think, hypotheses, models, iterative processes, interim provisional explanations, probability eventually, somewhat later, acceptance of uncertainties, all of these things are scientific methods for managing failure, for managing it in a non-catastrophic way. And then finally, of course, in order to traffic around in nothing but ignorance and failure, you better develop something that gets you up in the morning, right? That doesn't leave you in some totally depressed state. And so I think it develops a kind of an optimism. And that's to achieve scientific knowledge, is sort of a kind of a permissive attitude has to be cultivated. And that would be what I would call optimism. And then from that, a sense of progress emerges, the notion that, yes, we can, in fact, find things out. We can, in fact, accumulate knowledge. We can ask better questions. And that this eventually enters into and pervades the wider culture as well. And that much of our optimism today is actually this scientific optimism, to the extent we're optimistic. So I'd say the key ideas here are these guys: ignorance, experiments, failure, optimism, and the notion of progress. So what's still left? Well, progress is a very tricky issue. There's lots of stuff written on it. I can't even begin to go into it all here now. We don't have a good definition for it. There's a difference between progress to and progress from, for example. We traffic in these heroic narratives and arcs of discovery about science, that this is the way it progresses. You go, from Kepler to Newton to this one, that one, Faraday, blah, 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 and then Einstein, voila, physics, there you go. But we know that's not really the case. There are lots of failures and wrong turns and all sorts of bad things happen in the middle. Determinism is a kind of a curious business in science and optimism, because if you think you have universal laws, then what happens to free will, creativity, and things like that? Pluralism, which I think is a crucial part of scientific optimism, but is hard to practice, that you have many expertises and they can be incommensurable. Uncertainty, of course, we've talked about a little bit, that this idea, I've stolen this from Charles Gillespie, the famous historian of science, that in science, revision is a victory. I think it's a crucial idea. Skepticism, how are you an optimistic skeptic? But I think that's what science sort of does. Value, of course, there's always interesting issues about value and progress in science, ethics or not, the sort of golem image. And then what's worthy science? Do we want only core science, fundamental science, or applied science, or what's the correct dynamic between the two? Something I think we still haven't really figured out very much. So all of these things I think are yet to be figured out when talking about optimism in science, and this is what I'd like to sort of work on. So, optimistics. Half full, half empty. You'll have to answer this one for yourselves. All right, I'd like to have a discussion now, if we could. Have I ended in time? Thank you all very much.
So we have this microphone that we're going to pass around so your question can be heard. And anyone who has a question, raise your hand. I'll come to you. Yeah, I'll get my cardio.
Thank you very much for a very instructive lecture. And I agree with almost everything that you said. And if you are speaking to a bunch of educated people, they can understand exactly what you mean by failure and ignorance and so on. But those words worry me because how you differentiate between the kind of ignorance that you are talking about and the kind of ignorance that we are witnessing with the highest politician on the land.
Yeah, well, so we live in what I hope is an unusual moment in time that will not be regularly repeated or things like that. I'm being optimistic, perhaps, but the question was there beforehand. Obviously, I mean, it's easy to place it in this character, but you notice I'm avoiding the name, but it was there beforehand, and I agree with you. But I think it's important in some ways to be provocative in that way, to say, look, uncertainty, doubt, not knowing, and failing are what makes science so successful. This is what has made it go. Because if you don't say it, and you kind of try and, I don't know, just talk about the greatest discoveries today and all the rest of that, eventually you don't get funding from NIH or NSF because they come to believe in the greatest discoveries too. And the Congress people who, apportion the budget come to believe in a greatest discoveries view of science. And then that's all they want to fund. And then when it comes to something like climate change and somebody goes, yeah, well, it's probably this way, but look, there's a little wiggle room here, then all of a sudden you're really off the rails, right? So, I mean, this won't be an easy position to take, I'm sure. But I would say that scientists have bungled the climate change issue. And speaking to your point, I would say we've bungled it in the following way. I'm not really blaming anybody because it's only in retrospect that you can kind of see that we bungled it. So there's nobody to blame for it. But I'd say we bungled it because I think the way we should have approached climate science is, wow, we have these new technologies, satellites, geophysical technologies. We've been able to make measurements of climate over long periods of time on this planet. And we find that the climate is changing, that there are clear changes in the climate, some of which must be due to human activity. But here's the thing. First of all, we have this fabulous technology that shows this. And secondly, we can fix this. We could figure this out. We could put people on the moon. We could do this. We need a Sputnik moment in climate change, not what we have instead, which is dire warnings, dystopian predictions, and all the rest of that, which are, I think, intended to sort of scare people and which are not going to get people out of their cars because we're not really giving them an alternative, and which I think in the end have had a bad influence, a bad effect on developing new technologies. So I think we've traipsed out solar technology and wind technology long before we should have. There should have been far more development in both of those areas because they're not going to work in the end, I don't believe. There should have been more research in nuclear technology and a more sensible approach to it. All of these things I think would have been more possible if we hadn't made an emergency out of it somehow or another, but made an optimistic, we're going to live through this, we're going to get through this on this planet. So I think you have to kind of at some point just be upfront with people that this is the way it goes. And yeah, I know. Some people will say, well, you're just ignorant and failing. What do we need you for? But they're the same people that have an iPhone in their pocket, so they know they need us, right? And they're going to go to the doctor and take the drugs and all the rest of that.
So if you're upfront about it, how do you do that in a way that ends up being...
If you
want to be upfront about that, how do you do it in a way that's positive? And I'm thinking from a number of points of view. This lecture was a lot to do with the practice of science. I actually have a fridge magnet, fail again, fail better, for my students. But I have two questions. One is, do you believe that science gives uncertainty, not certainty? Would that be a suitable point of discussion? And secondly, in the broader picture, I was just wondering your comments on something that I came across fairly recently, and it's the merchants of doubt and how the merchants of doubt can use this uncertainty to negate everything. So how do we bridge the professional to the public? I mean, that's
right. So there's sort of two questions in there a little bit, but So I think the first way is that you use things like ignorance, failure, doubt, and uncertainty to make science actually more accessible to a public, to say to them, this is a great adventure. And you can understand it by understanding what you've done. So, you know, I teach this course called Ignorance at Columbia. That's how I sort of got into this whole business, because I got tired of teaching this. I still have to teach it, but I got tired of teaching this course called Cell and Molecular Neuroscience, which has, you know, 25 lectures, a 1,400-page book that weighs 7.5 pounds, which I'll point out is twice the weight of a normal human brain. But nonetheless, that's what we have. And, you know, it's one of those fact-filled courses. But it does the wrong thing. I mean, at the end of a class, at the end of a semester, I think, well, these students have two ideas about neuroscience that are dead wrong. One is we know almost everything there is to know about the brain. How could you not with a book that big? And secondly, the job of scientists is to find stuff out and put it in these books that we have to memorize. Neither of those things have anything to do with reality or the way things go. So what's the sense of that? So it seems to me, so this class in ignorance is interesting for me, or has been an interesting adventure, because what I basically do is I invite members of the science faculty at Columbia or in New York or anybody traveling through to come in once a week. The class meets for 2 hours and talk to students about what they don't know. No PowerPoint, no lecture, no preparation. Just come in the way you walk into the lab in the morning and talk about what you don't know. Why do you choose this question instead of that one? What makes this question important when all these other questions are there? What are some of the other questions? What if you don't get to know this? What if you do get to know this? Then what will happen? All these kinds of ideas. And curiously, you can bring in a particle physicist, a mathematician even. That was the hardest one, but nonetheless, even a mathematician, let alone chemists, geologists, biologists of all sorts. And they can talk to people in a way that's understandable, that if I asked them to come in and give a guest lecture, either nobody would attend, or everybody would be lost, including myself, within the first few sentences probably, no matter how much they tried to dumb it down. So I don't think the issue is to try and give the public a dumbed down version of science. The issue is to let them into the process, and the process is a puzzle, and everybody loves a puzzle. So why not let them in on the secret that we're working this stuff out, and here's the adventure. And I was asked that question, I'm sorry to go on so long about this, but I was asked that question at a group of fundraisers who I talked to from medical school. And one of them raised their hand and said, well, how can I raise money when I tell people we don't know and we fail? And I said, that's exactly how you raise money. We don't know, we need to know, we fail a lot, but when we succeed, we really succeed great. That's what you're putting your money into. It's a game. You'd go to Las Vegas and place a bet, wouldn't you? You buy a lottery ticket, you bet on sports. So I think that's the kind of attitude you have to somehow promulgate. The other thing, very quickly, the merchants of doubt business, that's just a nefarious use of ignorance. And that to me is a political issue more than a scientific issue. It's this notion that the tobacco industry invented this and now the climate industry or the energy industry is using it, which is to promulgate the little bit of doubt about the science into something that says we shouldn't act, we shouldn't do anything, we need to find more out. You know, there's a wonderful book about this called The Merchants of Doubt is Naomi Oreskes. There's an earlier one called The Golden something or other by Robert Parker is his name, Stanford. Maybe that's the one about tobacco. Which, you know, the tobacco industry, all the research that shows you that smoking is bad for your health was financed by the tobacco industry. All of it. $200 million worth of research. And they did that because they could say, well, we need to research this. And it took 10 or 15 years, during which time they sold $20 billion a year worth of cigarettes. So $200 million in research was worth every penny of it.
So you said everyone likes a puzzle, but it seems like not everyone likes to fail at a puzzle. And I think your point of scientists are comfortable with failure is a very good one. But how do you make more people comfortable with failure? Or another way of thinking about it is how do you screen for successful scientists by their comfort with failure?
I'm going to answer just a slightly different question, if I can. I'll get to that one too if you really want me to. But because I know there's a big worry right now about how we train scientists, STEM education and all the rest of that. I don't think there's a crisis, personally. Because you read about STEM education, we don't have enough scientists, we're going to run out, and then the next week in Nature, you read an editorial that says we're training too many PhDs, there are no jobs for them, there's no funding for their research, you got to stop turning out all these PhDs. I don't know, which way do you want it here, right? I think we train scientists just fine. And if you want more of them, there's a very simple solution to it. Fund the research, make positions, pay them some money so they don't have to go into the financial industry. Then you can have more scientists. It's a very simple solution. The people I worry about more are everybody who's not going to be a scientist as a profession. And for them, their last formal interaction with science was probably their high school science classes, and maybe some required physics for poets class at college, which is even worse than the high school science classes were. So these are the people I worry about, because they're going to go on to be, I don't know, journalists, corporate leaders, whatever, voters, I don't care. And they're the ones who have all these distorted views of science where, it doesn't fail, it's always right, it knows the facts, it knows this. And then when it suddenly comes up wrong about something, or it suddenly changes its mind, they're all like, oh, what's this? This is not the science I learned about. So I think that's the sort of bigger problem. I would also say very quickly that, so I have a colleague at Teachers College, which is part of Columbia University. Her name is Xiaodong Lin. And she's working on a very interesting thing where she's shown that if you include short narratives about the failures that famous scientists have had and the struggles they've had into the curriculum, the students do better in their science class, because they feel that science is not just about geniuses having eureka moments, which it's not. So she uses a narrative of Marie Curie as a woman, of Michael Faraday as not a rich old white guy, but an untrained white guy, but nonetheless, not in the same class as the other guys, and Albert Einstein, who suffered from all sorts of problems with the Nazis and so forth. So, and she finds that the more you tell students about the way science fails as well as the way it succeeds, the more accessible it becomes to them. They don't feel, oh, well, science, got to be a genius to do that. Yeah, I'm no genius, I'll do something else.
So I have the mic, so I'm going to ask
Sorry.
the next question. It kind of follows off of this one. So I admit I have a bias because I'm trained as a historian, but the number of times I've heard you say retrospective, retroactive, talking about sort of past examples of science, it seems like maybe failure might not be the answer, but potentially history might be the answer. And I wanted to ask you about, in your book, you talk about how one of the things you make your students do is go back and read 10 years ago journals from science. Could you talk a little bit about that, maybe, and
Sure.
whether
Well,
it
I mean,
speaks to the whole history as an
yeah,
answer?
Yeah, sure. This is sort of more the ignorance thing than the failure thing, I would say. But it's a very common thing. If you run a lab, invariably every couple of weeks, some student runs into your office with this week's issue of Nature and some fabulous paper, and then they go, "Wow, look at this paper. This is great. We could do the next experiment. This is obvious. We'll do the next experiment." And then I have to say to them, "Well, these people have already done the next 3 experiments, or they wouldn't have published this paper. So it's too late. It's too late." But where you can go to get good ideas for experiments is to Nature or Science or one of these fancy journals 10 or 15 years ago. Because there were papers published then. They were good papers. They're perfectly okay. It's not that they're wrong, but in the ensuing 10 or 15 years, there are technologies and new ideas that have developed and new models for all these things, and there are wide open questions available in those papers that those people didn't know they didn't know. And that's where you want to go for ideas. You want to look back a ways. So yes, but we never teach a historical perspective in science classes. I mean, the worst is, science education. I mean, I went through undergraduate as a science major and didn't learn the crucial things until I got to graduate school, which is nobody gives a shit what you know. They want to know what you don't know. They want to know what question you have to ask,
Maybe that would be a good place to end.
Yeah?
Oh, you have a
One more?
question. Hannah has
Go
a
on,
question. Hold on.
Oh,
One more
Hannah
question.
did a lot of work on this. She deserves to ask a question.
So there's a problem in science called the file drawer problem, right? So
Called
the file drawer problem,
Yeah.
where people, their failures and their non-successful studies just kind of shoved off, and we don't publish them. We don't have the opportunity to learn from them. What's your recommendation to solve that problem for people who have already failed and failed and
all right.
failed?
So I'm sorry that you let her ask this question because it's not a short answer, but I'll try and make it a short answer. There are a lot of people interested in this now, and I think for the first time we have the possibility of actually sort of getting to a solution. This is the problem of negative results. So what do you do with negative results? Given that we fail most of the time, most of what we have in our databases, our labs, and our lab books are negative results, which are nonetheless, of course, informative and very useful. And will tell you, even if they don't give you any additional information, they tell you a lot about the process or this or that. But we don't publish them. You can't publish negative results. And there are some actually good reasons for not being able to publish all the negative results, because we already have too much to read. And there are a lot of reasons why a result could be negative, some of which are legitimate and some aren't. Maybe the people that couldn't get the result just are crappy scientists or didn't have the right resources, or this or that. So it shouldn't be a reason not to do an experiment. All those sorts of things. But I think now with this newfangled internet thing, so to speak, I think you could wind up with negative results. And at first I thought, well, we could have a repository for negative results. So the issue with negative results for students especially, and postdocs, who would be the people publishing these negative results, because they're the ones who get them, is that you need to have them citable. They need to be citation worthy. Otherwise, there's no inherent value in this for them to do it, right? And so the only way you find out about negative results is you go to a conference and you go to the bar and you get somebody full of beer and you say, so did that work? They go, no, don't try that. So, but now I think you could do it on the internet and they could be citable. I think an even better way to do it would be to begin publishing papers in which we embed the negative results as links inside the paper, so that you can always get to the negative results that were also behind it. I have to recommend this article by Sir Peter Medawar. Peter Medawar was an immunologist, Nobel Prize winning immunologist in England in the 1950s and 60s. And he was sort of like the Carl Sagan of England. He was a popularizer of science, as well as being a great scientist himself. And he wrote an article in a magazine called the Saturday Review. It's available online, called "Is the Scientific Paper a Fraud?" And the answer is yes. It's yes, because the scientific paper is not written in a narrative way that it actually happened, right? So the chronology of a scientific paper has nothing to do with the order in which the experiments were done. And it never includes the failures or all the wrong turns or the things like that. It's reassembled in some narratively sensible way. I always tell my students, if you're reading a paper and at some point they start a paragraph with, "we reasoned that," everything from there on in is bullshit. You can be sure that was not the case. That was definitely not the case. And so I think, though, you could now embed these ideas, these negative results and these missteps and things like that inside a regular paper, so that you would have it citable and available without having to have a whole separate thing. That's just one idea. But it's a very important issue. You're absolutely right.
So
All right, now I'll shut up.
Let's thank Dr. Firestein.
Thank you all. I appreciate it.